Welcome to another lesson on probability. Last time we defined probability as being a measure of how likely something is to happen. For example, Gerard and Refilwe investigated whether a drawing pin would always land point up. From that investigation, it was clear that a drawing pin does not always land point up. Sometimes it lands point down. But what does sometimes actually mean? In that investigation, we showed that a drawing pin has an equal chance of landing point up or point down. About half the time it will land point up and about half the time it will land point down. So half is a more accurate measurement than sometimes. We represented this on a probability scale, a number line that represents probability measurements. Now we're going to look at more probability measurements, how to represent them and how to calculate them. By the end of this lesson, you should be able to calculate the probability of an event and state whether the possible outcomes of a trial are equally likely to occur. Gerard and Refilwe enjoyed their last investigation so much, they decided to get more ambitious. They heard their friend boasting, "I can always taste the difference between Cola, Cola and others straight away." Always ready for a challenge, they decided to set up a test to see how many people really could tell the difference between colas. Let's see what they did. This should be interesting.
We've set the table with 4 cups filled with different kinds of cola.
And one of these cups has koala cola in it.
Yes, so what we need to do right now is find some people who can tell the difference and taste our cola.
Right, but nothing tricky. See, we both know that cup number 3 has the koala cola in it, but they don't. So let's go see if they can figure it out.
Before they start their investigation, let's work out what the probabilities are here. A person will taste cola from 4 different cups and then say which one is Cola Cola. Now, let's say you haven't got a clue, so you just guess. What is the chance that you'll be guessing the correct one? Well, there are 4 possibilities. It could be this one, this one, this one, or this one. So we have 4 possible outcomes, but only one of them has Cola Cola in it. That means only 1 out of the 4 possible outcomes will be correct. In other words, only 1 out of 4 possible outcomes will be the favorable outcome. And the 1 out of 4 is normally written like a fraction. Probabilities are written like this: the number of the favorable outcomes out of the total number of possible outcomes. But there's one thing we need to be careful of when we use a fraction to calculate probability. Each of the possible outcomes must have an equally likely chance of occurring. That doesn't mean each outcome will occur the same number of times. It means that each outcome has the same chance of occurring. In other words, none of the possible outcomes has an unfair advantage over the others. Let me show you what I mean by using these 3 socks. If I take 1 navy sock and 2 white socks, all the same size and material, and put them in a tub of water, what is each sock's chance of touching the bottom first? Well, we can't tell what the chances are until we check whether the socks are likely to sink at the same speed. We can see that the socks are the same size. We need to check if they have the same mass too. Then we would need to make sure that we drop them at the same time and from exactly the same height. So let's assume they do have the same mass and we manage to drop them into the water from the same height at the same time. Now we can say that all 3 socks have an equally likely chance of sinking to the bottom first. The total number of possible outcomes is 3 because we have 3 socks. So each sock's chance of reaching the bottom first is 1 out of 3. What is the chance of a navy sock touching the bottom first? Well, the total number of possible outcomes is still 3 because each sock has a fair chance of sinking first. And there is only 1 navy sock, so the favorable outcome is 1. That means there is a 1 in 3 chance of a navy sock sinking first. Now, what is the probability of a white sock sinking first? Well, the total number of possible outcomes is still 3, but there are 2 white socks, so there are 2 favorable outcomes. So there's a 2 in 3 chance of a white sock sinking first. So the probability of a white sock reaching the bottom first is double the probability of a navy sock reaching the bottom first. 2/3 is double 1/3. But what if I fill the navy sock with sand? Now that I've heavily weighted the navy sock, the chances of it sinking to the bottom first is greater. So the chance each sock has of reaching the bottom first is no longer equal. I've given the navy sock an advantage over the white socks. It has more than a 1 in 3 chance of touching the bottom of the tub first. Because I weighted the navy sock, I have made the chance of each sock reaching the bottom first unequal to each other. In a case like this, our rule won't work anymore. We can't use the probability calculation, number of favorable outcomes out of total number of possible outcomes. This calculation can only be used when each of the possible outcomes has the same chance of occurring. Now let's go back to our cups of cola. There's no way the drinker can tell just by looking at the cups which one has which kind of cola. None of them has been given an unfair advantage over the other, so the possible outcomes are all equally likely. That means that we can use the formula. Favorable outcomes out of total number of possible outcomes. So, if a person has no idea which cup has the Coca-Cola and they just guess, they have a 1 in 4 chance of being right. Now, let's go back and see how Gerard and Refilwe are getting on with their investigation. Oh, and remember, cup number 3 has the Coca-Cola in it.
I can tell Coca-Cola from other colas. It doesn't matter which one I drink first. They're all okay. But I can soon tell if it's not Coca-Cola.
Excellent.
Right. Okay. Take a sip from each of these cups.
I'm pretty sure it's this one.
Very impressive. It seems like you really do know your cola.
But hang on. It could have been just a lucky guess.
Okay, test me again, and I won't look. Pour out some new cups, and I'll have another go.
But when will we be sure that she really does know her Coca-Cola? How many times does she have to get it right?
Well, look at it like this. She could have just guessed, right? She already had 1 in 4 chance of being right. Which means, on average, if a person is just guessing, they'll only get it right once in every 4 tries. But if a person can really tell the difference, then they should get it right more often than that. So she needs to do the test 4 times, and we need to see how many times she gets it right out of 4 trials.
Hey guys, I'm thirsty and it's free cola, so bring it on.
All right, coming up.
She's right again. That's 2 out of 4 times.
You know what? Let's do it again just to be sure.
Alrighty. Let's see if 3rd time is lucky. Brilliant. I think she really does know her stuff.
I think we should stop right here. 3 out of 3 is pretty convincing. Even if she does get the 4th one wrong, it'll still mean that she got 3 out of 4 correct answers.
Then, Gerard and Refilwe did something very interesting. They added another type of cola. Now the people they test must choose from 5 cups. If a person is just guessing, what is the probability of him or her choosing the right cup? The number of favorable outcomes is still only 1. There's only 1 cup of Coca-Cola. But the total number of possible outcomes has gone up to 5. So a person now has 1 in 5 chances of being right. In other words, it's getting harder to be right just by guessing.
It's this one.
Sorry, but was that a wild guess? Try again.
No. I actually don't know. I think it's this one.
It's definitely this one.
Well done, but you have to do it again so you know you're not guessing.
It's this one.
By this stage, people were queuing up to be tested. Actually, I think they all just wanted some free cola. So now, Jared and Rufila tried something different. They set up a trial using 6 cups. This time, 3 of the cups had cola in them, and the other 3 had other kinds of cola in them. Now, let's work out if a person just guesses which one is a cola. What are the chances of them being right? The total number of possible outcomes is 6, so that's our denominator. And the number of favorable outcomes is now 3 because 3 of the cups have the cola. So they have a 3 in 6 chance of being right, which can be simplified to 1 out of 2, which is of course a half. So now, if a person can't tell the difference between the colas, then whatever they guess, they have the same chance of being right as of being wrong.
It seems some people do actually know koala cola from other colas.
But there were also quite a lot of people who actually didn't know and were just guessing.
How about trying that experiment yourselves? Remember to work out what the probability is of a person just guessing and make sure they do the test a few times. Their number of correct guesses out of the number of tests they do must be higher than the probability of just guessing. For example, if you have 4 cups, then the chance of being right is 1 in 4, which is 1/4. If you test a person 4 times and they get it right 3 of those 4 times, that's the same as 3/4. 3/4 is higher than 1/4, so you can conclude that that person probably does know which one is cola. Now, let's summarize what we've learned in this lesson. To calculate the probability of something occurring, we must work out the number of favorable outcomes out of the total number of possible outcomes. Remember that you can only use this calculation when each of the possible outcomes has an equal or fair chance of happening. Now it's your turn. For each question, write down the number of possible outcomes, the number of favorable outcomes, the probability statement as a fraction. What is the probability of getting tails if you flip a coin? Guessing the correct answer in a question with choices A, B, C, or D. Drawing one of the 4 aces from a pack of 52 playing cards. Picking a red jelly tot from a packet of 7 yellow, 10 red, and 9 green jelly tots. Put the probabilities of the above questions in order from lowest to highest. Now it's my turn to do the cola test. I'm not an expert in telling the difference between colas, but I'm going to enjoy trying. Until next time, cheers.